Oh, goodness, guys. Strap in. It's Professor O.M. Mitchell again and his lectures on astronomy. Okay, this is number 4, and this is essay number 86, by the way. And so we've had many essays with Professor Mitchell here, and I think we can agree at this point he's boring, he's pompous, he's kind of annoying, but you know what? We're here to do the democratic thing and read through this entire book of essays. It's a lot of essays. This book was published in 1865. It's called American Miscellany, and we're here on page 209. We've just finished an interesting little essay called Winter Traveling in Russia, and you know what? We're going to get through it. We are going to power through Professor O.M. Mitchell and his lectures on astronomy. This is number 4 of his lectures on astronomy. All right, we find that all of the planets of which we have any knowledge are revolving upon axes and all rotate in the same direction on their axes that they move in their orbits. Now, as the Earth is sweeping around the Sun, it is held stationary to that great center by the attraction of gravitation, but it would be held in its position even if it did not rotate upon its axis at all. Gravitation has nothing whatever to do with the rotation on its axis. But again, we find the Earth sweeping around the Sun in an orbit, the plane of which is located in a particular position in the heavens. Now, gravity would have held the Earth equally steady to this center, if that orbit, instead of sweeping in the direction it now does, had revolved in any other direction whatever, forming any possible angle with the present orbit. Once more, we find all the planets revolve about the Sun in planes nearly coincident, traveling on in nearly the same direction. Gravity has nothing whatever to do with the inclination of their planes, nor with the starting of these planets in their orbits. If they had revolved in contrary directions, gravity would have held them just as perfectly. And indeed, we find a full confirmation of this truth in the fact that the comets which come in from every possible section of the heavens observe no particular direction either in the position of their orbits or the manner in which they sweep around the Sun. They too are governed, as are the planets, by the laws of gravitation. Now the question arises at this point: is there no evidence of design in the structure of our systems that it was built in this way? Why do not all the planets sweep in any direction at all consistent with the law of gravitation and having their planes inclined in any possible way as the comets? I will answer it, and I think in a way satisfactory to every mind. If the system had thus been constructed, it would have contained within itself the seeds of its own destruction. It never could have endured. The time would have come when the planets would have rushed madly from their spheres, and the whole system have been swept to utter destruction. We find that in order to preserve the stability of this beautiful system, it is necessary that these planets should revolve in the same direction and that the planes of their orbits should be nearly coincident with each other. And furthermore, that the law of gravitation has nothing whatever to do with the localities of the planets. Suppose, for example, that Jupiter could be snatched from its present orbit and could occupy that which the Earth now occupies. And we could throw the Earth out to fill the mighty orbit of Jupiter. Gravity would hold each of these equally steady. But then, even were all other bodies to move on in the position they now do, or in any combination which now exists, such an event would produce destruction. It is not possible to change places with any of these bodies and at the same time preserve the stability of the whole. Let us then mark the difference between what is absolutely dependent and what is not dependent upon these laws. And in this difference, we see that an almighty power has adjusted this vast machinery, and that it has been formed in infinite wisdom and with infinite skill. With these views, I shall proceed to the examination of the system with reference to those bodies recently discovered. But before I proceed, it will be necessary to make some explanation with regard to certain matters involved in this discussion. At first, this matter of perturbation. I know this subject is somewhat difficult to understand, but a few words, I think, will be sufficient to render it quite plain. Suppose the sun to be located at a given point, at a distance equal to the shortest distance of the planet Mercury from the sun. We locate that planet. This is its perihelion. Next, let us place Venus, then the Earth, and so on with all the planets, all located in a right line and in their perihelion, or nearest position to the sun. Suppose they receive the primary influence which starts them on their mighty journeys. Now, will they all come round again to occupy the starting point after a single revolution? No. Will these perihelion points remain in a right line after the first revolution? No. The very moment they start, they begin to operate upon each other through the forces of attraction, and all the elements of every orbit begin to be swayed backward and forward. These changes are going on perpetually. These perihelion points are moving onward, their eccentricities continually changing, and millions of years will roll round, when at length, at the expiration of some mighty and almost inconceivable cycle, when this great timepiece of eternity shall have struck one, they will all occupy their original relative position and once more start on their immense journey. We have a little applause break here, by the way. We have here in parentheses, applause. I don't know if applause happened or if he just wrote that into his speech, expecting applause from the students. Okay. Now, this being the case, how is it possible for the human mind to reach any knowledge of the influence of these bodies mutually on each other? For if the limits of their orbits are continually shifting, there must be some difficulty in getting at that influence. For before you can make any use of established positions, they are changed again. This is all literally true, and the astronomer is obliged to seize every one of them, and even the sun himself, and weigh them in a balance. He is obliged to ascertain the amount of matter belonging to each and all of them, and when he shall have attained to this knowledge, he must then compute the influence which each exerts upon the other, and thus, with long and patient toil, trace out all their devious wanderings. I shall now attempt to explain how it is that the weight of these distant orbs is determined. How can we weigh this earth against the sun? How can we place them, as it were, in some mighty balance and ascertain precisely how much one preponderates over the other? Follow me, if you please, in a very brief exposition of this problem. In the first place, the power of gravitation upon any body is determined, as all know, by the amount of velocity it is capable of producing in a falling body in 1 unit of time. If at the Earth's surface a body falls 16 feet in the first second of time, that is the measure of the intensity of gravity at that point. But if this earth did not contain the element which is now in it, if it were smaller, a body would not fall so far in a second of time. There is a certain law establishing this, which we have ascertained. I have already stated that the moon is ever falling towards the earth, and the amount by which it falls is measured. We know it exactly, hence we know precisely the influence exerted upon the moon by the earth. And that is the first point. Now suppose on the opposite side of the moon there was another earth, and it were as large as ours and equally distant, but contained double the weight of matter. At the same distance it would produce twice the effect of our earth. Increase its magnitude to 3 times, and the effect is increased in like proportion. Now there is no such Now there is no such other earth, but there is the sun, and let us attempt to ascertain the comparative weight of the sun and the earth by weighing the amount of action which each exerts upon the moon. In the first place, then, the moon is attracted by the earth and is caused to fall through a certain distance in a given time. Secondly, the earth itself is attracted by the sun and is caused to fall through a certain space in a certain time. Now, with reference to the magnitude of the sun, I think the moon and the earth may be regarded as equal. It is exactly like dropping two weights, one of 1 pound and the other of 2 pounds, to the earth. They will both fall with the same velocity. So with the moon and the earth, the difference of their masses may be regarded as absolutely nothing. Now the sun deflects the earth from a tangent line by a certain amount which measures its influence upon the earth. Likewise, the earth deflects the moon by an amount which measures the intensity of its force upon that satellite. The amount of deflection produced in the orbit of the earth is more than double that exerted by the earth upon the moon. Hence, if the sun were equally distant from the moon with the earth, it should be twice as heavy as the earth, because it produces twice as much effect. But the truth is, it is not at an equal distance. It is 400 times further off. If, then, at this distance it produces twice the effect of the earth itself, we must increase it in the ratio of the square of 400, or 160,000. This number must be multiplied into the exact ratio of the influence of the two, as already estimated at an equal distance, which carries it up to 354,436 earths. And that is the precise ratio existing between the mass of the earth and the sun. Thus it is that we are able literally and absolutely to weigh these bodies one against another. Hence every satellite which revolves about its primary planet gives us the means of weighing that primary. But what is to be done in cases where there are no satellites? Here the problem is more difficult. The influence exerted by other planets on these bodies in swaying them from the paths which they otherwise would have pursued tell us the amount of matter belonging to them. In this way, astronomers have attained to a most accurate knowledge of the value of the mass of all the planets. It is true that in the instance of Jupiter, Laplace, in his earlier computations, made it out different from subsequent discoveries. He said that it would require 1,067 Jupiters to make a mass equal to the sun. He reached this conclusion from a series of observations made by the astronomer Puond, and when he had examined them all critically, he said that the mass could not be in error by 1/100th part of its value, and that the chance of its varying to that amount was as 11 millions to 1. He had brought all the powers of analysis itself into the calculations, and the probabilities of his being in error were as I have stated. But it seemed as if chance was not to have its peculiar dominion invaded in this way. And, if I may be allowed to use the expression, chance determined to chastise the hand that had ventured to draw aside the curtain and unveil her mysteries, for it has been proved most positively that one chance out of 11 millions was the one that turned up, and Laplace was wrong. Applause. Okay. I guess applause did happen. Okay. I don't know if you expected that. Okay, so we have a little applause break here. The fact was the measurements had been made indifferently and a long time ago. He had used a computation made upon a little body called Encke's comet, and from the ethereal mass of the elements of this ghost of a world, so filmy that it had not the power to lessen even the light of the smallest stars that shine through it, he had made his calculation of the mighty orb of Jupiter. The mass of Jupiter, as computed by Laplace, was employed to determine how much disturbance existed there, and there was not enough. So when this mass was applied to other calculations and suspicions were aroused that it was inaccurately calculated, it excited other measurements until at length all agreed very accurately in giving the mass of Jupiter such that 1,049 such bodies would make one sun. We proceed now to the structure of our system. It will be remembered by all who heard me in my second lecture that the older planets were for a long time known. They are arranged according to a very curious law with reference to their distance from the Sun. It is known, for example, that when passing out from the Sun to Mercury and from Mercury to Venus, there is a certain ratio of distance, which holds true in regard to the distance of the other planets, for an immense space of 350 million miles, until you come to a mighty gulf within which no planet was known to revolve, and the moment that limit was passed, the old law resumed. This curious law was detected by Bode. I will explain the law in a simple manner. Beginning with the first of this series as nothing and assuming 3 for the first distance, we have the following series: 0, 3, 6, 12, 24, 48, 96, and so on. This is obtained by multiplying each succeeding term by 2. Now, if you add 4 to every term of the series, you have another series as follows: 4, 7, 10, 16, 28, 52, 100. Sorry, these are labeled. So Mercury is labeled 4, Venus 7, Earth 10, Mars 16, we have a blank spot for 28, and then Jupiter is 52, and Saturn is at 100, and so on. This latter series represents most accurately the distance of all the planets from the Sun, but in passing from Mars to Jupiter, the link was broken. There was no planet to fill up the space, and when Baron de Sac detected this law and found it to be perfect in every other instance, he came to the conclusion, and could not resist the conviction, that a planet unknown revolved in that space. Such was his absolute conviction that he actually commenced a computation of its orbit in 1784. He made out its distance and published the elements of its orbit 15 years before any bodies were known to exist in that space. In the year 1800, such was the effect produced by his investigations that a congress of astronomers met in Lilienthal to unite upon a plan for hunting down this unknown body. They agreed to divide the whole region into zones, 24 in number, or 1 to each astronomer. They commenced their labors on the first day of the first year of the present century, and before they had hardly commenced, one of their number detected a small star which did not exist on his chart, although he had laid down upon it, as he supposed, all the fixed stars. His name was Piazzi of Palermo. With what anxiety did he wait till the following night again to examine this stranger! When the next night came round, to his inexpressible delight, he found it had changed its position, and was actually retrograding as a planet ought to do. But he did not venture to believe he had so soon discovered this unknown wanderer, and only told his friends he had found a very suspicious body, and supposed it might be a comet, but he could not tell. It looked very much like a planet. Baron de Sac, when he heard of this discovery, at once seized it, saying, "This is my planet, which I have so long predicted." He took a few observations, but in consequence of the fact that it soon fell into the rays of the sun, only a few observations could be made, so that, but for the extraordinary discovery of other bodies, by other observations at short intervals, it could not have been known to be a planet. But Baron de Sac at once commenced a computation of its orbit. They had all agreed in assigning to it exactly the place that could be occupied, in order to make a law of relative distance which had previously been thought to exist, apply in this last instance. Baron de Sac knew the planet was found, and when he compared his own investigations with those which were found to result from actual observation, it was discovered that he had predicted its place precisely. When all the astronomical world was rejoicing in the beautiful law and the complete establishment of the harmony of the system, another object was found. Another planet was detected which seemed to have an orbit precisely similar to the one already found. Here was a most astonishing anomaly, 2 planets revolving in orbits nearly coincident. The like was to be seen nowhere else in the entire system. What could be the meaning of this? How happened it that these 2 little bodies occupied this place and with orbits so nearly equal? Others conceived the idea that they were fragments of a former mighty planet, which by the action of some powerful force had been rent asunder and scattered in every direction. Strange theory this, passing strange. But follow me through this curious history and then decide if there be any foundation for its truth and whether it is merely an astronomical dream. In a very short time, to the astonishment of the world, Harding finds another planet. There are 3. Olbers was confirmed in the opinion that his theory was true, and said he, if this convulsion did take place, and the fragments were scattered, then, inasmuch as they started from the same point, they must all revolve to that same point in their orbits. If he could find the place where their orbits intersected or crossed each other, which we have already explained as the nodes, inasmuch as these were common points, it might be true such a disruption had taken place. It was on this hypothesis that, after watching from night to night and from year to year in the particular region of this node, they finally detected a 4th body. Here, at length, were 4 bodies revolving in nearly the same orbits, and thus the truth of this wonderful hypothesis was verified. Again, an investigation was made to ascertain the amount of force necessary to burst a planet and separate its fragments. Lagrange demonstrated this with a force 150 times greater than that given to a cannonball. The particles would sweep off in an orbit called the parabola, but that the force of 20 times would give elliptic orbits of different degrees of eccentricity. There is also another point. In case this theory was true, the larger fragment would occupy more nearly the orbit described by the original body, and the smaller one revolve more obliquely to the plane of the ecliptic. This was found to be the fact. In comparing their bodies and their orbits, some of the smaller ones made an angle as high as 30 degrees with the plane of the ecliptic, and had exceeded the plane of the zodiac, which confines all the rest of the planets. When they were thus fixed and determined, and after 14 years of examination all had been done that seemed could be done, and the investigation need not continue any further with the hope of success, many years rolled round, and finally, in December 1845, we hear announced that another of the asteroids had been added to the 4. Astrea, discovered by Encke of Dresden. He was prosecuting this examination for the purpose of finding the nodes of the asteroids, and on the plane that had been previously adopted, having more accurate charts of the heavens with the stars more carefully laid down. The moment he detected a new star, he suspected it of being a planet, and a few evenings would always settle the investigation, and in this way he detected Astrea. For 2 years he continues, when lo, he has found another planet, and Hebe is added to our system. But he had scarcely described it, when Heinz, an Englishman, had fished up another, Iris, and before we know the name given to this one, the same astronomer announces another, and Flora is joined to the other 7. Thus we have the beautiful phenomenon of a group of 8 sisters revolving around the sun in orbits of nearly equal magnitude in periods absolutely identical. All occupy the center of the space between the planets Mars and Jupiter, and by their joint action, their joint mass, their joint distances, fulfilling this beautiful law of Baron de Sac. Having gone through the examination of those objects, I shall proceed to give an account of the planet Jupiter. This is the largest in our system and one of the oldest known. We have, indeed, no knowledge of the time when this beautiful orb was unknown. Go back to the pages of history as far as you please, go even beyond the limits of tradition, still you find that this planet was known to the earliest inhabitants. How do we know this? Some will have already inquired. Let me tell you. If we go to the records of the earliest nations, we find invariably this curious fact, that the days of the week, 7 in number, are named after the planets, counting the sun and moon. Thus, the sun, the moon, Mars, Mercury, Venus, Jupiter, Saturn. Every nation, the Chinese, the Egyptians, the Persians, the Chaldeans, have applied the names of the planets to the days of the week. They do not, to be sure, begin the week on the same day, but beginning with their first day, they run round the cycle exactly in the same order. There is but one way of explaining this remarkable coincidence, and that is, they must have received this from some nation anterior to them, to either of them. It must have come down from the same common origin. Hence, we run back anterior to tradition itself to find the first discovery of these planets. In this beautiful planet, Jupiter, we find one that fastened the gaze of the earliest minds that turned their attention to the heavens, and by possibility it may have been detected before Venus, for Jupiter is seen at all possible distances from the Sun, while Venus is always comparatively near. When the telescope was first directed to this wonderful orb, a sight was revealed to the astonished gaze of old Galileo that seemed almost to stupefy his mind. There were 4 beautiful moons revolving about this noble orb, obedient to its attraction. You all remember that at this time this discovery was made, the battle was raging between the old and new school of philosophers, those who believed with Ptolemy and those who followed Copernicus. Galileo had become a convert to Copernicus, stood up the champion of truth, and fortunately for the world, armed himself with a power that all the antagonism of earth could not withstand. "You tell me," said he, "the earth is the great center about which the universe is revolving. Now I tell you that yonder globe shows a miniature system like our own. And while we have a single moon, there is a planet which has no less than 4. Do not then attempt to impose this impossibility upon me. I do not believe it." He combated those who opposed the progress of truth, till finally he incurred the displeasure of the Church itself. You all know the fact that, borne down by the weight of years, he was brought before the Inquisition and forced to recant his opinions in the most solemn manner. But such was the power of truth that in spite of all the threatening by which he was surrounded, as he rose from his knees, he stamped upon the earth and said, "She does move, though." It seems that Jupiter and its satellites were given for a most valuable purpose, and I ask your attention to but 1 or 2 of their uses. And first, the fact that they served to determine the velocity of light. I know many minds revolt from the conclusion which astronomers have reached when they say that light flies 12 millions of miles in a minute, and that there are objects so distant that their light would require the enormous period of 50,000 years to reach our Earth. In the language of my old friend, this is a hard story. It is incredible, but before this course of lectures closes, I intend to show clearly and positively how this has been determined and how much reliance is to be placed upon this wonderful revelation. Previous to the discovery of the satellites of Jupiter and their eclipses, it was believed that light passed instantaneously over the most distant space. It was believed that if a lamp was lighted and the eye could see it through the space of millions of miles, that the instant it was lighted, the eye, if it directed towards it, would see the light. On the discovery of Jupiter's satellites, they were found revolving in such orbits that in every revolution, the 3 interior ones were always eclipsed and disappeared from sight. It did not require a long series of observations before the astronomer began to predict the coming of their eclipses as we do those of the moon. He examines the result of his computation and after a while detects a certain amount of discrepancy between the observations at the 2 opposite points of its orbit. He tries again, but in spite of all efforts, after long years of toil, he could not reconcile the predictions exactly with the observations. And then he began to inquire if by possibility there could not be a law which reconciled them. Let me endeavor to show how this was attained. Suppose the Earth to be at a given point in its orbit, and Jupiter to be in that part of its orbit on that same side of the Earth. The distance which separates them is precisely the difference of the distance of their orbits from the Sun. But let the Earth revolve around to the opposite side of the Sun and Jupiter remain as before. The distance is now increased by the whole diameter of the Earth's orbit, 190 million miles. Now the observer on the Earth, when nearest to Jupiter, will in the eclipse of its satellite see the light disappear too soon according to the computation. Why? Because the stream of light is shorter by an amount equal to the whole diameter of this orbit, and consequently runs out more quickly. When he takes his observation from the opposite side of the Earth's orbit, he finds the eclipse comes on too late, because the stream has 190 million miles further to run. And of course, he will continue to see the satellite till the stream runs out. Now then, in this way, we are able to determine how long it takes light to pass across the Earth's orbit. Then, by ascertaining the exact difference in these extreme points, this single calculation of the velocity of light would account for all the discrepancies and reconcile theory and observation in the most perfect manner. But to pass across this orbit requires 16 minutes. Hence, the velocity must be at the rate of 12 million of miles in a minute. Here, then, is the foundation upon which this result was first rested. Well, some skeptical mind will say, that is only a single observation. Give me confirmation of it from some other sources, or I must reject it, so astonishing a result. For a long time, the astronomer was at fault, and the skeptic had in some sense the advantage. But at length a better series of observations are at hand. In certain examinations of the fixed stars, it is found that these little points of light, when critically examined, appear to be moving according to a certain law and describing a minute orbit. The cause of this was perplexing to the astronomer and baffled all the efforts of one of the strongest minds that ever gave its powers to this subject. But finally the explanation was discovered in the fact that it was owing to the effect produced by the aberration of light, that as the Earth swept round its orbit, the light in coming to us caused the body to appear in different positions from that in which it then occupied. Let's try that again. But finally the explanation was discovered in the fact that it was owing to the effect produced by the aberration of light, that as the Earth swept around its own orbit, the light coming in to us caused the body to appear in different positions from that in which it then occupied. Let me make this intelligible. Suppose you desire to cross a river and the stream will carry you down and you wish to land at a point fixed upon the opposite shore. Will you start out from an exact opposite point and row directly across to the opposite shore? By no means, because you know you will in that case land below. Now how far above will you make your starting point? Just as far above as the current will carry you down in the time you expect to occupy in crossing. But what has this to do with the velocity of light? I will tell you. Every particle of light that leaves yonder orb in coming towards us sweeps downward in the direction of a right line. And when the astronomer turns his telescope to receive that point of light and to cause it to pass down the axis of the tube, he must take into account the fact that he himself is moving with a certain velocity. As he is borne on by the movement of the earth, he must take in the other fact that every particle of light is coming with a certain velocity, and he must incline his instrument so as to cause it to pass down its axis. The amount of inclination depends on the velocity of light, as the distance you would be carried down the river depends on the velocity of the water. And when we have inclined our tube so that the visual ray shall hit the mark, that inclination is precisely what ought to be given it. Upon all this calculation, it is found that light travels 12 million miles in a minute. Here is confirmation strong and irresistible. But one step further, it is found that certain stars are united together, not a planet revolving around sun, but two mighty suns revolving about each other. To this matter I will call your attention more particularly hereafter. In a certain system of double stars which had engaged the scrutiny of the very ablest minds, there were found discrepancies between the observations and computations which could not be reconciled for a long time. The problem seemed utterly beyond our reach, but at last, within a short time, one of the German astronomers discovered that the whole difficulty has grown out of the fact that the velocity of light was not taken into the account, and that the fact that the star was sweeping around a mighty orbit and thus impressing its own motion upon the particles of light was not considered. When it was, all the discrepancies disappeared, and the velocity of light comes out precisely as before. Here, then, are three demonstrations from different sources, all coinciding. I will not say exactly, but nearly so. The reason why I do not say exactly is this. A very short time ago, I received a communication from M. Struve, a Russian astronomer, who said he was engaged upon the subject of the velocity of light and had determined what is called the constant aberration of the fixed stars, and found the value for them was a little different from that obtained in regard to the satellites of Jupiter. There was a slight variation, and perhaps a thousandth part of the whole. Yet it could be measured, and he said that it was impossible that there might be a difference between the velocity of direct and reflected light. And he begs me, in consequence of the peculiar position of my observatory being more advantageous than his, to furnish a series of eclipses of the first satellite of Jupiter through the next 10 years, with a view to determine thereby any difference between the actual velocity of direct and reflected light. This is the kind of accuracy attempted to be attained in our own day, and this, in truth, is the accuracy which is actually reached. You may think it is spending time in vain to work for 10 years to settle a question in which the discrepancy gives you only a second decimal place, but how important it is to know whether this mysterious element in the original movement of light is different from that when it impinges upon the surface reflecting it, will be perceived when we reflect that of the computational affects will be perceived when we reflect that the computation affects the movements of all these bodies, and that by a correct calculation of this apparently insignificant feature, we attain to a degree of accuracy that we cannot reach in any other way.